Okay, welcome to lesson 12. In this lesson, we're going to be discussing linear functions. Now, there's a lot to understand about linear functions, and so what I'm going to do at first is I'm going to go through 7 just basic facts about linear functions, and if you understand and have these 7 basic facts about linear functions, you should be able to answer almost any question about linear functions. Okay, so we're going to start with this first one, and this is we're going to see if we can identify linear expressions. The importance of a linear expression is a linear expression is basically an expression that has a variable that is of power 1, and that's it. It can't be a power 1 variable plus a power 2 variable. It has to just be an expression. It can have as many numbers in it as it wants to have, and the numbers can take on any form, but the variable has to be a first power variable. And let me give you an example right away here, right off the bat, this is a linear expression, okay? X plus 5. You can see that this is x to the first power, and then what we're doing is we're taking x to the first power and adding 5. The plus 5 is fine, it's irrelevant. The most important thing is that we have a variable and that it is to the first power. But this one over here, this says x to the second power plus 5, or x squared plus 5. X squared plus 5 is a quadratic expression, and therefore this is not a linear expression. Okay? This one right here, 4 times x, this is 4 times x to the first power. So this is a linear expression. But this one over here says 4 to the power of x. That's not what we're looking for here. It's okay for x to be multiplied by 4, but not 4 to the power of x. This is what's called an exponential expression, and therefore that is not a linear expression. This one here, this is a linear expression. We have 3 squared. You might say, yeah, but what about the exponent? Yeah, 3 to the second power, that's just 9. Plus 4 over 7, a fraction, that's fine, times x, x to the first power. So a number plus a number times x to the first power, this is a linear expression. But this is not a linear expression. This is 2 minus 4 over x. Now you may say, but look, we have the 5 times x to the first power. And that's fine. This by itself would be a linear expression. But because it includes 4 over x, we have x in the denominator of a fraction. Anytime we have a variable in the denominator of a fraction, it's automatically a rational expression. So this is not a linear expression. It's a rational expression. Similarly here, we have 7x minus 1 over 5. Over 5 is fine. This is not a variable. We can have a fraction. This is 7 times x to the first power minus 1 over 5. Just so you know, this is the same thing as 7/5 x minus 1/5. It's the same thing, okay? And so we have x to the first power here. But this right here is 7x minus 1 over x. So this is a rational expression. This one's okay, that's a linear expression. But this one right here, this is a rational expression. Over here, we have n plus 5 times 2 plus 3n. This is going to be okay because when we distribute the 5 over here, we wind up getting n plus 10 plus 15n. And when we add n plus 15n, we wind up with 10 plus 16n. This is n to the first power. That's okay. This one is also okay. 4t plus 3t, that equals 7t. 7t to the first power. But this one is not okay. When we distribute this n, we're going to get n times 2, which is 2n, and then n times 3n, which is going to be 3n squared, and because we have the n squared, it's quadratic. It's not linear. Same thing here. 4t times 3t is going to be 12t squared, and so that's a quadratic, not a linear. Okay? And so if you can identify a linear expression, you're in really good shape.